We will now find the general solution of this given differential equation. So we have this differential equation xy prime equals 3y plus x power 4 cos x. And we are also given this initial condition y of pi equals 0. Using this initial condition, we will also find the particular solution. So first, we are going to find the general solution. I'm going to find the general solution of this differential equation using the integrating factor method. And here I have outlined the steps of integrating factor method. So basically, we will be following these 5 steps to find the general solution of this given differential equation. So let's do step 1. In step 1, we have to write the differential equation in dy by dx plus p of x y equal to q of x form. So I'm going to write down this equation in this form. First, let me rewrite this y prime as dy by dx. So I can write down this as x times of, sorry about it. This is dy by dx equals 3y plus x power 4 cos x. And since we have to write down in dy by dx, we should not have this x, which means we can divide both sides by this quantity x. So first I divide by x. I will then have dy by dx equals, I have to divide the terms on the right side by x. So therefore this becomes 3y over x plus x power 4 cos x over x. We can cancel this x power 4 with x as x cubed times. So this is equal to 3y by x plus x cube cos x. And to bring it into this form, I'm going to subtract this term, that is 3y by x, on both sides. So when I do that, I'll be getting dy by dx minus of 3y by x. I'm going to write down this as 3 by x times of y, and this equals x cube cos x. So now we have successfully written the given differential equation into this form, where p of x and q of x are functions of x. Maybe we can identify the p of x. So this quantity is the p of x, that is this expression, which is p of x equal to negative 3 by cos x. I'm sorry, negative 3 by x. And the terms or the expression on the right side is the q of x, and this should be a function of x. We can easily verify that it is a function of x, that is q of x equals x cube times of cos x. So we have written this in the dy by dx form, which means we have completed the step 1. Let's do step 2 now. That is, we have to find the integrating factor given by integrating factor equals e raised to the power of integral of p of x dx. So let's do the step 2. We find the integrating factor, and this is given by e raised to the power of integral of p of x dx. So now I'm going to substitute p of x, which is negative 3 over x, into this formula for integrating factor. So therefore this becomes e raised to the power of negative of 3 by x times of dx. So basically we have to integrate this negative 3 by x. So we can write on this as e raised to the power of, I can factor the negative 3 and then integrate only the 1 by x and dx. So integration of 1 by x is natural logarithm of x. So therefore this becomes 3 times of natural logarithm of x. We can rewrite this in using the properties of logarithm, that is this will get raised to the power of x. So therefore this becomes e raised to the power of natural logarithm of x raised to the power of minus 3, or we can write down this as e raised to the power of natural logarithm of x raised to the power of 1 minus 3 can be written as 1 by x power 3. So then we can still further simplify this. We know that e as well as this natural logarithm are both inverse to each other, so they cancel out each other, and giving us 1 over x power 3. So basically this is the expression or the result of integrating factor. So we have determined the integrating factor, which is 1 over x power 3. Now let's do step 3 as well as step 4 combined. In step 3, we have to multiply both sides of the equation in step 1, that is the equation in this form, by the integrating factor, and we will also have to write down this as d by dx of integrating factor times y equals integrating factor times of q of x. So we will do the step 3 first. So I'm going to multiply this equation, both sides of this equation, by the integrating factor. So when I do that, I have to multiply each term by the 1 over x power 3. So therefore, this becomes 1 over x power 3 times of dy by dx minus of 3 by x y times of 1 over x power 3, and this equals x power 3 cos x times of 1 over x power 3. We see that we can cancel these two x power 3, so they get cancelled, and we are going to get as this expression. And in fact, this expression is basically the derivative of the integrating factor. That is, we are now doing this step 4. So in step 4, we can write down the above this left side expression as d by dx of integrating factor, which is 1 by x power 3 times of y, and this equals integrating factor, which is 1 by x power 3 times of q of x. So the q of x is x cube cos x, x cube times of cos x. So we can still cancel this, or we have already done this step. So this is equivalent to only cos x. We will have only cos x here when we do it. So I'm going to write down this side expression as cos x, which means we have completed the step 4. And finally, in step 5, we have to integrate both sides of this equation so that we solve for y. So let's integrate both sides. We do this integration. And notice that integration of a derivative function, we will get only this function or only this expression after the derivative. So therefore, when we integrate this side, we will get only 1 by x cube times of y, and this equals, we have a dx over here. So integration of cos x is sin x plus the integrating constant, we put it as c. Now we have to solve for y, which means we can multiply this equation by x cube. So when we do that, we get y on this side, and this will become x cube times of sin x plus cx cube. So basically, this is the general solution of the given differential equation. That is, y equals x cube sin x plus cx cube, where c is the integrating constant. We will now find the particular solution of this differential equation. We are going to use this general solution as well as this initial condition to find the particular solution. So what we do here is we take this initial condition, substitute into this general solution, and determine the integrating constant c, and then put back the value of c into the general solution. That will help us to give the particular solution. So let's do that. So at x equal to pi, that is when x equal to pi, y equals 0. This is the initial condition that we are given. So let's plug it into this general solution. I'm going to replace x by pi and y by 0. So therefore this becomes 0 equals x equal to pi. So this becomes pi cube sine times of sine of pi plus c times of pi cube. And we know that the value of sine pi, this quantity equal to 0. So therefore this completely becomes 0, and we have 0 equals 0 plus c times of pi cube, which is pi cube c, and this implies pi cube c equals 0, and c is also 0. So we determine that the value of c equal to 0. Let's plug the value of c into this general solution, and when we do that, we get the particular solution. So therefore, we can write the particular solution is y equal x cube sine x plus c is 0, so therefore it becomes 0 times of x cube. So this quantity completely becomes 0. And finally, we have the particular solution as y equals x cube sine x. So we found the particular solution of this given differential equation.